Let's look at another example. Let's add 4 over x minus 3 plus 7 over x minus 2. Now x minus 3 will not factor. So I'm getting it. So the first step would be to get the least common denominator. So x minus 3 will not factor, so I've just got to leave it as x minus 3. X plus 2 will not factor either, so I've got to write it out to the side as well as x plus 2. So your least common denominator is going to be the x minus 3 times the x plus 2. Now the second step, once we find the least common denominator, which is x minus 3 over x plus 2, then I write both of these fractions as the equivalent fraction having the common denominator. So I'm going to rewrite these exactly as they are. 4 over x minus 3 plus 7 over x plus 2. Now you have to ask yourself the question, what do I multiply x minus 3 by to get the common denominator? Well, in order to get x minus 3 times x plus 2, I have to multiply the x minus 3 by the x plus 2. So I must multiply the denominator by x plus 2. If I multiply the denominator by x plus 2, then I multiply the numerator by the same thing. So the key is I'm multiplying both numerator and denominator by x plus 2. Now we go to this fraction. What do I multiply x plus 2 by to get x minus 3 times x plus 2? Well, the answer is x minus 3. So I have to multiply the denominator by x minus 3. If I multiply the denominator by x minus 3, then I've got to multiply the numerator by the same thing. So I multiply the numerator and denominator by the same thing. I need to multiply the numerators, so I would have 4x plus 8. 4 times x is 4x, 4 times 2 is 8, over x minus 3 times x plus 2, plus 7x minus 21. 7 times x is 7x, 7 times 3 is 21, over x plus 2 times x minus 3. Now you might be wondering why I decided to distribute and multiply the numerators, and whereas I left the denominators factored. Well, the reason goes back to the rule. The rule says keep the denominator. If I'm going to keep it, I don't need to do anything to it. So I'm just leaving it factored. But the rule says keep the denominator and add the numerators. By the order of operations, you must multiply before you add. So I had to multiply the expressions through and distribute before I could perform the addition. Now the step does say now this was step 2 here, in which we expressed as equivalent fractions having the common denominator. Now step 3 says keep the denominator, x minus 3 times x plus 2, and add the numerators. Well, I'm just going to indicate that would be 4x plus 8 plus 7x minus 21. Now normally speaking you'll do this step in your head, but I wanted to show you that I'm simply adding the numerators. Now I'm going to simplify. 4x plus 7x is 11x, and 8 subtract 21 is a negative 13. So I have 11x minus 13 over the denominator of x minus 3 times x plus 2. I would reduce if I could, but you can only reduce if you can factor, and since I can't factor 11x minus 13, I know that I cannot reduce. So the answer is 11x minus 13 divided by x minus 3 times x plus 2. The problems can get harder. Let's look at 2x minus 1 divided by x squared plus 4x plus 4 plus x divided by x squared minus 4. First step, we need to get the LCD. Well, to get the LCD, I need to do the factoring. So I'm coming over and I'm going to factor x squared plus 4x plus 4 into x plus 2 times x plus 2. Now I need to factor x squared minus 4. X squared minus 4 is the difference of two squares. I know the difference of two squares is x minus 2 times x plus 2. Well, I do not have anywhere to put the x minus 2, so I'm going to put it out here. But I can line up one of the x plus 2's with one of the other. So notice I line up my factors when I can. So I line x plus 2 from the x squared minus 4 with one of the x plus 2's from the x squared plus 4x plus 4. So my LCD is going to be x plus 2 times x plus 2 times x minus 2. Notice I'm just coming down. And that will always give you your least common denominator. Now I'm simply going to rewrite my problem and leave space to multiply. So I have 2x minus 1 over, and I'm going to leave the denominator factored, x plus 2 times x plus 2 plus x over x minus 2 times x plus 2. So now take time and look at the screen to see what I've done. All I have done is I've recopied the problem and I've left space to multiply. I really haven't left as much space as I should have on the first one, but anyway, I've left space. Now the whole key to adding fractions is going back and multiplying by what it takes to get the least common denominator. Now listen closely. I need to multiply by what it takes to get my least common denominator. I have an x plus 2. I have an x plus 2. So what I need is x minus 2. So I multiply the denominator by x minus 2. If I multiply the denominator by x minus 2, then I multiply the numerator by x minus 2. So I have multiplied both the numerator and the denominator by x minus 2. Now for the second one, I have an x minus 2 and an x plus 2, but I'm missing this x plus 2. So I have the x minus 2, I have the x plus 2, but I need another x plus 2. So I multiply the denominator by x plus 2. If I multiply the denominator by x plus 2, then to keep everything equal, I must multiply the numerator by x plus 2. So I multiply the numerator and the denominator by x plus 2. Now I'm going to multiply the numerators. Remember, I must multiply before I add, and the rule says keep the denominator, add the numerators. So I'm not going to do anything to the denominators, but I am going to add the numerators. I'm just writing down the denominators now, so I won't do anything to them. But I'm going to multiply through so I can add later. I'm going to use the for method on this one.